All right, so the last example we're going to do is that type where we want to take u equal to ax plus by plus c. And the example to solve it is going to be dy dx equal to minus 2x plus y squared minus 7. And because I told you that we're taking u equal to ax plus by plus c, there's going to be a temptation to sort of say, okay, well, I see 2x plus y there, sorry, minus 2x plus y, and then I've got the 7 there, so I guess that's my u. Because I know sometimes you all see like a bunch of numbers in a problem given to you, you see like a format, you know it's supposed to match, so you just plug them in so it matches. But for this u, I want to make sure you understand that you don't need every single letter. You know, some of them can be 0. The only one you really need is the middle term. And so for us, that 7 isn't actually part of it. Our u is just minus 2x plus y. And the reason for that is because we want to be able to write dy dx equal to f of something. And so our something is that right there. That is, our f of u is going to end up being u squared minus 7. And you'll see that when we plug it in. But if u is equal to minus 2x plus y, then y is u plus 2x. And we have the derivative, dy dx, because we know that we have to get rid of the y derivative if we switch to using u as our variable, is d dx of y, so u plus 2x. And so that's just going to be sort of distributing the derivative because of linearity of derivatives, du dx plus 2. And so we just want to plug everything into our ODE. So we started with dy dx equal to minus 2x plus y squared minus 7. So our dy dx we just said is du dx plus 2. And our minus 2x plus y becomes u squared minus 7. That's where that big F comes from. And then just trying to isolate our derivative, we're going to see that du dx is u squared minus 9, or du over u squared minus 9 is equal to dx. So on this next slide, I went ahead and did fraction decomposition because this is a separable equation. I'm going to have to integrate both sides, so I'm going to have to integrate u squared minus 9. 1 over that. And I didn't want you to watch me do fraction decomposition, so if you want to like pause and look at this, do that. But our answer is that when you integrate, you get minus 1 over 6 natural log of u plus 3 plus 1 over 6 natural log u plus 3. And so you can combine those with natural log rules to be the natural log of u minus 3 over u plus 3. Natural log of a minus b is natural log of a over b. And the integral of dx, I did not do ahead of time because I thought we could get through that pretty quickly. It's equal to x. So natural log of u minus 3 over u plus 3, x plus a constant, is equal to 6x plus a constant. I just moved my 1 over 6 over just now. And so u minus 3 over u plus 3 is equal to some constant times e to the 6x. Remember, e to the 6x plus c is e to the 6x times e to the c is a constant times e to the 6x. I'm not changing the notation on that c every time it changes because it's just an unknown number to me right now. Really, that became like 6c and then e to the c, but I didn't want to do that. So u minus 3 is u plus 3 times c e to the 6x. So u minus 3 is cu e to the 6x plus c 3c e to the 6x. Now that c appears in 2 places, I have to be careful with my algebra. So u times 1 minus c e to the 6x is equal to 3 times 1 plus c e to the 6x. just moving all my u's to one side and moving my minus 3 over. Or u is 1 plus c e to the 6x over 1 minus c e to the 6x, the solution. And I probably went through that algebra a little bit quick for you, so you might want to pause and just make sure you followed all those steps. It's just that I don't think it's a great use of your time for me to explain algebra when I'm sure that you all have gotten lots of practice with these exponents in the separable equations stuff at this point. So that was the last example. Our next wrap up is I'm just going to go over everything. So watch that when you have a second.